Всем привет, меня зовут Никита Соболев, и это лучший курс по питону. Сегодня необычный выпуск, так сказать, специальный, особенный, потому что и гость у нас сегодня специальный и особенный. Сегодня я поговорю с другим core-разработчиком питона, который очень много знает про то, как работает фритрейдинг, JIT, а также многие другие внутренние части питона, а также является членом Steering Council. Это такой специальный орган управления всея питоном. И, конечно же, я специально для вас подготовил русские субтитры. Вы можете включить их прямо на YouTube и слушать на английском и читать на русском, если вам будет так проще. Английские субтитры тоже есть, так что вы можете использовать их, если хотите. Мне очень хочется, чтобы все питонисты понимали, как на самом деле работает управление таким большим проектом, как самый популярный язык программирования в мире. Потому что это тоже внезапно инженерная задача. Конечно, не каждый из нас будет сталкиваться с этим в реальной жизни. Однако ничего нам не мешает посмотреть на то, как это действительно работает, и привнести в свою жизнь что-то новое и интересное. Многие до сих пор ошибочно полагают, что Гвидо Монросум принимает все решения самостоятельно. Однако это не так. Теперь питоном управляет Steering Council. Это выборный комитет из 5 человек, который каждый год меняется. В него может попасть любой core-разработчик и даже не core-разработчик. Именно Steering Council отвечает за то, какие пепы будут приняты, а какие пепы будут отклонены. То есть это буквально 5 человек, которые определяют судьбу всего Python. Сегодня я пригласил одного из них для того, чтобы поговорить про весь этот процесс. Ну и, конечно же, когда тебе такой человек приходит в гости, нельзя не поспрашивать его про другие интересные темы. Например, Дон Хина – один из больших участников проекта Free Trading. Также мы несколько затронем вопрос джита, потому что ровно сейчас рассматривается PEP, который поменяет то, как работает JIT, и от этого его очень интересно обсудить. Ну и также поговорим, вернее, затронем такие две темы, как Reproducible Builds и Bolt. Для тех, кто не знает, что это, конечно же, мы все расскажем внутри. Ну, а теперь к самому интервью. Приступим. Danhina, it is really nice to have you here. You're very talented developer and steering console member. And today we're going to talk about your Python contributions, your steering console work, and a lot of stuff around CPython. So thanks a lot for joining, and please introduce yourself.
Okay, hi. So my name is Dong Hee, and I'm from Seoul, South Korea. And I've started to contribute to CPython from 2017, and I've promoted to the CPython core dApps around 2020. And then I'm now working as the steering council member from this year. So and these days I'm focusing on the presetting works and better CPython thing stuff. So I really enjoy to contribute to the open source project related to the CPython stuff. Yeah.
Yeah, it's really great because you were the first person to introduce me to the Python triage team back in 2021 or 2022, something like that. And I'm still grateful for that. Thank you. It was a really big fun to work as a triager and to learn all the Python workflow and all the internals. Can you please explain to my audience what steering console is?
Yeah, so the Python Steering Council is kind of a small group of the Python core devs that are elected to oversee the development and direction of the Python language. So from 2018, and after the Guido's resignation from the BDFL, the first Steering Council are actually formed, and the Guido was one of the member of the first year. And the Steering Council, the primary responsibility of the Steering Council is the managing the path process and decision for which path will be accepted or not. And then we also manage the kind of the core devs event, including the Python Language Summit and the core sprint stuff and etc. Yeah, there's a lot of management stuff are actually management by the Steering Council people. Yeah.
So basically, the steering council is a group of 5 people who directs and controls all the evolution of C Python language. So basically, that's a big work, and these are the most talented and the most knowledgeable engineers in the Python core dev team. So I think that a lot of people should appreciate their work because it is really, really hard to move such a project. And can you please tell me about what is the daily job of a steering council member? What do you do daily? What are your like duties?
Yeah, so yeah, this might be my first life change after I elected a student council member, because like before I elected the student council member, to be honest, I didn't read the PAP as many as these days, but after I elected the student council member, I often read the PAP, three PAPs in a week, and we actually discuss the bunch of PAPs every weekly meeting. So in a weekly meeting, we met at my time zone is 5 a.m. Around 6 a.m. Friday, and we meet weekly and we discuss the bunch of the PAP that are that are listed on our task, and then we discussed uh, about each of the path that why it should be accepted, or why it should be rejected, or why it should be more updated to be more persuadable path for the student council members. That's our normal task. And then the other stuffs are actually included, including like, as you know, like once you promote the Python core devs, then you can get a travel grant for the US PyCon. Then we should execute it about the travel grant, and we need to discuss with the member of the PSF, and that kind of job are actually handled at every weekly meeting.
Hmm. So let's say that I want to write a PEP. What should I start with?
So if you are core devs, you can just write a PAP, and then you can just share the draft of PAP at the discuss at python.org, and then people will comment about your PAP, and then finally the student council member can review your PAP. But if you are not the core devs, you maybe need to find a person who will support your PAPs. So that's the main difference between if the author is the core dev or not. Yeah.
Let's say that I found someone from the core team who wants to sponsor this PEP that I wrote. What should I put in this PEP for it to be accepted? Like, what are the sections? What are the examples and stuff like this?
Yeah, so there's a lot of bunch of the paths that I actually accepted. So there's many kind of the path. Sometimes something is technical stuff and something is government stuff. So it's up to what you want to write. But if you want to write the technical path, so you maybe need to why this path is needed, and why this path will give an advantage for the Python users, and how we will not actually break a lot of things. It's very important for the Python student council member, because we are managing the very, very large of the code base in our world. So we are very careful of the compatibility. And then, and also you should persuade like how we will be effective, how we will be cover the a lot of code base, numerical statistics stuff. So that kind of stuff should be included in your pack. So it's not that different, the technical documentation that you are writing at the company. So if you're working at the company, like some people are actually writing the technical documentation, then it's same as that will be the same for the PAP if you write.
Okay. Do you have any personal goals as a steering council member? For example, do you have any big change that you want to achieve in the technical part of CPython or something like that?
Oh yes, there's two things. Like first thing is the technical stuff, and the other thing is the non-technical stuff. And so, talking about the technical stuff, as you know, I'm very interested in the free threading works.
Hmm.
So, I think that I try to support the successful ending for the free threading Python, and if there's something need to extra support, I try to support. And the other thing is the faster CPython stuff. There are many experimentation, include the JIT or tier 2 interpreter, and then the free threading and faster CPython have a common area, and then the collaboration is very, very important. So I try to support them. And also, these days, like the many people are actually talking about the ARM CPU, like
Mm-hmm.
not using the x86. So because of the ARM CPU is very efficient for the energy stuff or the cloud price stuff. So like people are very interested in using the ARM, but there's more effort is needed for the more optimized C Python at the ARM workload. So I try to support the people who work in them. So that's my main interest of technical stuff. And as you know, like the many of the core devs are actually stay in North America and
Mm-hmm.
in Europe, Western Europe maybe. So like APAC region, like Asia, Tokyo or Korea or Singapore or China, like there are just a few of the core devs are actually stay. So like I try to like represent like the company tech companies needs of when they're working on the C Python and try to uh, rep, like represent their needs, and also I try to organize the local core sprint, like that people can actually participate, even there's the few of the core devs stay in a specific regions. But so that's my main goal of the Streamcast member at this year.
Yeah, noble goals. I think that we should all support your deeds in these fields, because I think that free trading is a big feature and it should be the next milestone of the Python development and the next big milestone for the language itself. So, yeah, really appreciate it. We have one more question about your Steam console work. I think that there are a lot of interesting PEPs that you review, and maybe you can name some of them, like the most interesting ones to you, or like the most technically challenging, something like your top 3 PEPs that are in the works right now.
Okay, so I actually cannot pick the three paths at this moment. Like like there's a lot of rejected paths and just a few of them. So, but I can just pick one. So one of my best path of maybe this year for me is the path 765 written by Eric Carter. Is about the disallowing the return break continue that at the exit block. So because this paper is very well written, because like this is where researched in a free path. So like how many people are actually right or wrong use case of the Python statement, and I would actually suggest a way to how to fix people in a natural way without breaking any behavior. So for me is the best path of this year is because this very persuade, and it also provide the static stops, and it also provide a way to how to make people write a better code. So technical stuff or the non-technical stuff, I run a lot of things from this path. So for me, this path was a best path that I read at the until this February. Maybe after February, maybe the more stuff, but for me at this moment, this was the best path.
I agree. That's a really great PEP, and I think that it was one of the most problematic parts of the CPython syntax, and I think that a lot of real world code had this bug, and it's great that we have ways now to fix it in a wider sense. Okay, we also want to talk about your free trading work, because steering console is something like very few people touch, but free trading is something for everyone.
Yeah, my opinion.
Can you please explain what free trading is in a very brief words for people who are not familiar with this yet? Because 3.13 was not so long ago, and it still has this thing switched off by default.
Yeah, so I'm very happy to see that you are not using the term no gear. So actually, this okay. So basically, freeze threading is the project try to removing the gear And to be honest, this is the experimental stage of the CPython at this moment. And we are using the official term as the pre-threading instead of the no-gear. So if you are using the no-gear, then you should switch the term. So there's a lot of trial to remove the gear from the early year of the CPython, and many people try to, and many people are actually fair. But a few years ago, I cannot remember which years, but the 1 year, the Sam Gross, who works at Facebook AI Research, are actually sent a mail that he actually success to remove gear. And I believe that nobody believed that the project was successful at that moment. So like people say, please show your benchmark. And then Sam showed that the successful benchmark from the main release, and everybody becomes surprised. And after 2 years later, like because we need the time to analysis why this project was successful. Like there's a lot of components at the pre-threading, like using the mimalogs and BIOS reference count and something like that. So and after 2 years, like from Python 3.13, the many people are actually participate in a free threading project, and most of people are actually from the Meta, like because Meta funded the project for supporting the free threading project. So early stage, I actually have developed the initial CI for using the GitHub Action for the CPython because this is very technical, very basic stuff, because we need to verify like the no-gear free threading Python is working well. And then and another thing is that I was focusing on the making the Python runtime compatible with the free threading project, because like one of the biggest technical challenge we are maintaining the free threading Python is we don't want to make a lot of the fragmentations between the default build and the free threading build, because like if you remove the gear, like everything is non-thread safe. So at the Python runtime, we need to care about the data, the free thread and thread safe, but like there's a lock or critical section or atomic operation. So
you said two very important phrases of atomics and critical sections. Can you please explain what these are for a wider audience?
Okay, so critical section is section. It's section, but it will guarantee the thread safe without using a lock. It's simply if I explain. So nothing can be just one thread can involved in this section. So everything will be thread safe in this section. But the downside, of C code, and the downside of the critical section is might be could be a performance slowdown, because the other threads cannot involve at this section. So, but yeah, sometimes we need, and the atomic operation is not kind of section, but each of the operation can be processed in a single atomic way. So like even if the multiple thread is modified single atomic single integer, like it can be guaranteed that it modified is one by one. So but this does not guarantee the multiple of transaction between the multiple threads. So the use case can be different between the critical sections and atomic operation, but it's everything is happening in a C code base. So if you are just pure Python users, you don't have to care. But if you are the C extension maintainer, then maybe you need to care about it. Yeah,
you totally need to care about it, because you will totally need to support free trading in some time in the future. And basically, you can say it like this: atomic is primitives supported by the compiler. Critical section is our own concept that CPython maintains and supports as a feature. What about C extensions? Do authors of C extensions would need to support free trading soon?
Yes, definitely need. Yeah, maybe some of users does not need to change, but I believe that like when you think about why people actually writing a C extension, it's because of the performance issue. So there might be just pure C code that is not relating the Python object. So in that case, the multiple thread can be changed the C code, the C primitive stuff. So in that case, you need to care about the race conditions, and even you care about the Python object, if you are using the API that provides borrowed reference count, then it will not guarantee the thread safe. So you have to change to using the explicit reference count API. So and then if you care about this stuff, like if you search about the documentation, we already provide about it. So you can just read it and you can switch. And if there is something you need more API, then you can just file the issue, the CPython thing, PCPython repo, then people will interact with your needs. Yeah.
I think that reference counting changed quite a bit in the free trading build. Can you please specify how and what changed about it?
Yeah, it's very technically stuff, so I'm not sure I can explain very easily, but like in a simple way. Okay, so in a default gear, just one reference count. So this is why we need the gear at before the free threading build, because like if the multiple thread try to modify the reference count, just one reference count, so so we need to rock. So the rock is actually gear. So that's why we need gear at the default gear. But the free threading gear, there's two reference count. So one is shared reference count, and the other stuff was I can't remember one reference count, but it's for the reference count for the owner thread. So if you own the thread, this object, if the thread is on this object, this thread can modify this reference count by itself without any atomic operation or rock. So it will be very fast. And if the other thread share the object, they actually modify the shared reference count, and it will be modified atomic operation, and then it will be merged by the internal process. So it will be guaranteed that the thread safe of the total reference count. So the basic hypothesis of this approach is that the most of Python objects are actually owned by a single thread. So most of case, we don't care about the shared reference count, but some case, like there need to be shared for the other thread, then they will modify shared reference count, and there will be a little bit slow down, but we can overcome it. And if the sum object like code object is a good example that can be accessed by the multiple thread. In the case, we are actually using a default reference count, and this technique is delayed reference count at the stop the word the pages. So we overcome the multiple issue that will be happened when we remove the gear in our multiple techniques. So this is like what happened at the free threading build. I'm not sure this is the easy explanation, but yeah, this is my best effort.
Yeah. So, I think you did a great job. I really appreciate your explanation. Thank you. I also think that we should mention how new GC will work, because if we touched reference counts, I think it's fair to touch GC as well. Can you please share your thoughts about the future of GC and the work that is being done on it?
Yeah, so I'm not the expert of the GC, so I cannot explain like more stuff at this talk. But
yeah, me neither. I have no idea how it works inside. Yeah, it's too complex.
Yeah, but like the two stuff maybe like we introduced the stop the word, like it was not exist at the default build, so it will be existed of free threading build. And this is same mechanism if you're using Java or the other language, because we need to stop everything, and the GC need to collect the unused object. So this is why will be an important pages at the free threading build. The one other thing is like if I remember correctly, Mark Shannon is working on the incremental GC, and this is kind of not like it's same as the term, like it handled incrementally, so it can be expected like kind of more faster GC. But I cannot remember the progress of the incremental GC, so I think you maybe need to find about this. So yeah, so because I'm not the expert at this area.
I think that we had a very interesting bug back in 3.13 when in the last release candidate, the new GC was merged and it slowed down a lot of cases for like several noticeable percents, let's say it like this. And people were very fast to create new release candidate and to revert the GC change. And now we will have the new GC in 3.14. I think so. I hope at least, because this is a really big piece of work, and not a lot of people are aware of how hard it is to actually implement a garbage collector for language like Python with all the backward compatibility guarantees in place. So you said that you are very interested in ARM support and free trading support. Do you have any specific work or specific issues that you have in mind that are touching both of these topics?
Yeah, so like one thing I didn't talk at when I explained the free threading, like as you know, like Python 3.13 is just the kind of proof concept version of the free threading, and I know that people are actually disappointed with the single thread performance issue, like it's very slow. But like because like when the free threading are actual when it was introduced, if I remember correctly, it was based on the Python 3.9, and it didn't have the specializing interpreter that was written by Mark Shannon. He is very great man, yeah. So so when we port the Python free threading, we didn't port the special writer at the Python 3.13. So that's the main reason the free-threading was the single thread of free-threading is slow. So, but at the free 3.14, Matt Page and Matt Page and Ken Jin and Sam Gross and I and Thomas Water and a lot of people actually joined, and we success to port the most of case of the special writer to be safe with using the parse thread mechanism. So we actually ran the benchmark a few weeks ago between the default build and the pre-threading, and when it was 90% performance of the gear build, so it's a lot faster. So if you're using the free threading at the Python 3.14, you will not disappoint with the single thread performance issue. And more things like, like Kanjin is also introduced the Telcor dispatch. So and it can be used if the Python is built by Clang 19, and we noticed that the Python the free threading build with the Clang 19 and the Telcor dispatch is faster than 3.13 build. So you can enjoy everything. But if you are using the Telcor dispatch with the default build, it will be more faster. So like I'm not sure like how to explain, but like so many magical things as it will be happened at the Python 3.14. So you can enjoy it. Yeah. Simple explanation. There was many attempts to make Python bytecode dispatch logic be faster. So the one-up technique you are using is computed goto, and I think that this was the best effort for many years. But like from Clang 19, you can give a hint like for the taker. Is same term that if you run the algorithm like between the recursive core and taker, so like it will be more faster because it doesn't need more extra stack space and overhead, and it also provide kind of register optimization stuff. But it needs to be modified to be more familiar with the Telcor dispatch logic. So Kanjin actually writing a code generator to be more to be more familiar with the Telcor optimization, and then and if this Telcor dispatch is built by Clang 19, its performance enhancement is around almost 20%. So it is very amazing project. So I think you can expect it. And even if you don't know about the technical stuff about how Telcor dispatch works, but then you can just using the UV, and if you install the UV with the Python 3.9, if you're using the UV for installing Python 3.14,
Mhm.
as I know, they are already built the Python by Clang 19, so you can just using it. So yeah, this is very awesome feature, I expect.
Yeah, yeah,
Yeah.
it is one more optimization on even better than Computed Go 2 for bytecode dispatch, and you should totally give it a try. I think that it will be disabled by default for this release. Am I wrong?
Yeah, yeah, you're right. So because this is my personal opinion about this decision, but like this is not student council decisions, okay? So I we know I think I believe that the Telcor dispatch will not make a big trouble, but like we cannot guarantee any safety at this moment, because we need to know that actual people are using it and there could be a bug. So then we need to fix it. So but if you enable by default at the Python 3.14, when you get the feedback, might be take 1 or 2 years. It could be late. So like people will pay for with if the bug is raised. So the by default is disabled for guarantee the more stable provide. But as I said, the UV is actually providing the Telcor dispatch Python from Python 3.14, so you can just test it and using it. And if there's no problem, might be we can enable by default in the future.
Okay, I think that you've touched one more very interesting topic that I didn't specify in my previous notes, but for you. But reproducible build is also a very interesting big project that a lot of people are working right now. And can you please explain how is it related to UVPython and what is going on over there?
Yeah, so if you are using UV, it's not not the default distribute of the CPython. They are actually using the binary is actually based on the standalone Python is using the static build, and is focused on the compatibility with the multiple platform with just a single build. So this is very amazing project, because some of the people who works at like closed internet, like
Hmm.
in intranet, or like that, if there's no internet, like so it's just a one way to deploy the multiple Python in a way. So this is very amazing project. So if you're using the UV, yeah, you are maybe using the standard Python. Yeah.
Hmm. And so people from Astral is now working close with CPython devs to make reproducible builds easier and faster and less error prone, because there are some bugs. I think that a lot of problems on the reproducible builds are related to our bolt optimization. I saw like maybe 5 tickets about it, something like that.
Yeah, so we need to separate the topics with this issue, because as I said, the the static around Python is using a static build, like not dynamic linking is using a static build. So you can expect that the binary is very huge than
Hmm.
the normal Python binary. So they are actually using BERT. So BERT is one of the kind of the optimizer tool that is developed by the Meta people, and there's multiple compiler optimization technique is one. The basic stuff might be if you pass the option O1, O2, O3 to the GCC, the compiler will optimize your code. Their policy, and that's the one part of the optimization process. And the other stuff is PGO might be like it actually
Profile
gathered
guided
the
optimization.
It gathered the profile from your runtime and then regenerate the binary by the compiler. That we call like is no more compiler optimization process. But the another stuff is we call the post binary optimizer. So like if the binary is very huge, there is a lot of error cache miss ratio. If your binary is huge. So the one of the technique they are using is like the same as the PGO. They actually gather the profile two way. One is the instrumentation, and the other way is part like live in production traffic profiling, and then and they relocate the binary layout to be more optimized with the cache, error cache. So like if some code area is executed very frequently, they are clustered. And if is less executed area, they are separate to the code area, and then we can expect that the cache miss is reduced. And then they also eliminate unnecessary binary area. So like binary can be reduced. So that's why they are working on the board, because like they are major customer who are using the board, and that was provide maybe Python 3.10. I didn't remember correctly, but yeah. So this is why they are actually working on. Yeah.
I think that Bolt was introduced in Python 3.12.
Yeah, 12. Yeah.
Something like that. And I think that you were the person who contributed it. So it's one more big project from you. So let's give a credit.
But I have to say, like the board was actually a first attempt from the Python people, the people who worked at Dropbox, and then they developed the Python version 1 at the Dropbox, and then after they leave the Dropbox, they re-pretend like the fast C, they called faster C Python binary with the JIT, and we call it Python. And one of the optimization they are using was BERT. So we actually adopt their technique. So I want to say like the major works are done by those people, and my support was like supporting the well landing to the board in the C Python we can using it. So like I thank you for credit, but I need to like clarify like
also credit other people. Yeah.
Yeah.
Okay. So I think that I have one last technical question, but it is also very deep one. So let's prepare our audience for it. I think that in Python 3.14, there will be a big change to our JIT pipeline, because right now we require LLVM as a build time dependency. And it is proposed to eliminate that dependency in the build time. Do you have any information about it? Like what is going to happen and how it works?
Yeah, so like there's trial to remove the build dependency for the LLVM at the CPython, but there's PEP also, and Steering Council actually reviewed the PEP. So at this moment, I cannot say anything about the PEP. So yeah, this would be it's one of the cautious topic for me at this moment.
Okay, yeah, completely understand it. I think that we should put a link to this PEP in the description so people can read it and express their opinion in the discussion thread in the discourse if they have such opinions. So.
Yeah, but like this is my personal opinion, but if we successful rendering the JIT project, in the end, those kind of tasks will be needed. That will be very important path for the JIT project. But yeah, the decision will be handled by Steering Council, so I cannot say anything.
Okay. I don't have any opinion either because this is way out of my expertise area. So yeah. Okay, one last question about your other activity. You said that you also organize sprints in your hometown and that you invite people to join and participate. Can you please tell a little bit more about what these sprints are and what are the results and how you organize them? What should people do there?
Yeah, so every region there might be a lot of local sprint and for the C Python, but like in Korea or Japan or Thailand, maybe Russia, like like I know that there's no kind of sprint that are organized by core developers. So like some people may be difficult to participate in US PyCon because of the financial issues or a lot of stuff. So
Distance
like I
just.
it, yeah, or a distance financial or busy schedule. Yeah, who know. So I try to organize the sprint that you can working on the C Python like in a single day. Like and I try to provide how the manual about how you can contribute to C Python and how to you run the CI, how to run the unit test, and how can you write the code, and how can you can get a review from the C Python. So that is one of my trial to 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 organize a sprint at my local area because like I think that those kind of activity is like one of the way that people can involve the community driven language C Python like so people they represent their stance and what their needs and if they want to make a part of the issue like they can be more familiar. So I believe that such activity can make a more uh, interaction between the Python core teams and where the area that the just pure code have stayed. So yeah, that's one. So yeah.
Thank you. This is really great activity, and I hope one day to participate in such events or maybe even organize it because I completely agree. Letting people know that contributing to CPython is easy and fun is a big goal because a lot of people assume that it is like a hard work that is not fun, but it is a hard work that it is fun. And
Yeah.
I think that should be a lot of people should know that you can do it and you should do it. And I try to encourage people with my videos as well to contribute to CPython, to report issues about some unexpected behavior and stuff like that.
So like so this year like I'm not sure the more schedule but this year in my schedule maybe Korea I try to organize at around August. So if you visit Korea maybe Python KR is happening at August 15th. So you can join the sprint if you visit Korea. And I also plan to visit Thailand this year. So maybe if you have a plan to visit Thailand, maybe you can visit. And and if there's other chance, I try to support. Yeah, and I think that you also maybe organize kind of sprint. So if you need kind of resources that for the local sprint, I happily provide what I use for the local sprint at the Tokyo or Seoul or the other area.
Awesome. Thank you. And once again, very big respect for your work on CPython and your steering console work. We should really appreciate people like you and give credit for all the hard work they do for all of the rest of the world. Thanks again, and thank you for coming and giving this interview. And I hope people will enjoy it. And if you leave your contact, your GitHub handle, for example, and people will have some questions about free trading issues, and can they tag you?
Yeah, so I will provide my GitHub issue. My handle is actually is very weird names, Corona 10. Yeah, so like I know
It's not
most
related to
yeah,
to that
yeah, but
corona.
but people tend to so like but I'm using it before maybe 2019, so I don't care about. So my nickname, my handle at GitHub is Corona 10, and my Twitter is um, Dongina 92 is my birthday year, so you can interact with me if you want. And my mail is dongina, comma,
I will put
dongina,
everything in the description
yeah,
so people can contact you. Yeah.
yeah, python.org. So you can just send mail, and I will happily reply if you have any interest about contribute to C Python. And one thing I want to say to Nikita, you are also the awesome the core devs who interact the external contributors. So like I want to say also to thank you to all your activity at C Python. Yeah, I'm very respect about your every activities, including the triaging issues, fixing everything. Yeah, I'm very respect about your activity too. Yeah, thank you.
Thank you. Thank you. Bye-bye. А на этом у меня все. Надеюсь, было интересно, потому что мне во время интервью было действительно очень интересно. Я узнал очень много нового, я пообщался с потрясающим умным человеком, а это всегда очень приятно. И я надеюсь, что теперь вы тоже знаете о том, что можно управлять таким языком программирования, как Python. Это реалистичная цель для инженеров, которым это интересно. И я надеюсь, что, возможно, хотя бы одного из вас я смог мотивировать развиваться в эту сторону. Буду всячески рад помочь, если кто-то захотел. А у меня есть 3 замечательные ссылки, как обычно. Первая ссылка – это на GitHub. Вы можете поддержать мою работу там, поставив какие-нибудь звездочек, каких-нибудь форков. Вы можете поддержать мою работу на Boosty, если вы хотите поддержать рублем. Это всегда приятно. Я не предлагаю никакого-то уникального контента. Я считаю, что весь контент должен быть бесплатный и открыт для всех, поэтому это просто дополнительная мотивация для меня. Ну и, конечно же, мой телеграм-канал. Мой телеграм-канал – это такое место, где пишутся очень-очень много технических кишочков про Python. Поэтому, если вам нравится такой контент, тоже присоединяйтесь. Например, недавно я написал серию из 2 постов о том, как работает GIL в Python. И, естественно, я показывал код на C, который физически вызывает разные пишки Python и операционной системы для того, чтобы показать, как на самом деле происходит переключение GIL. Так что, если вам интересен текстовый контент про кишочки Python, смело залетайте. Ну и если вы хотите увидеть в гостях кого-нибудь конкретного, можете написать в комментарии, кого бы вы хотели увидеть, и я постараюсь пригласить этого человека и поговорить с ним о том, чем он занимается. На этом у меня все. Большое спасибо. Пока.